So today I wanted to discuss power valves. They're oftentimes the most overlooked part of a carburetor, but the power valve really is important to having a good, even, solid performance throughout your idle and cruising and your full throttle performance of your carburetor. But anyway, we'll quick go over here where the power valve is. So this is what a power valve looks like. All it is really a vacuum actuated diaphragm. It doesn't control the fuel flow. Actually, that's by some emulsion tube settings, and I'll show that in a bit. But anyway, they're numbered. So this one is just a standard one, so it doesn't have a number, but I believe with the carburetor it came in, it was supposed to be a 7.5. So when the vacuum of your engine drops to 7.5, this power valve will open. Now the vacuum on engines drop when you hit the throttle and they're under a load, and the more load they're under, the lower that this will actually drop. So, and why they're required is that when your manifold vacuum drops, you lose signal to your jets, so you don't have as much. The less manifold vacuum, the less pull effect you're getting through these jets, and so the power valve will open up, here it is here, and supply extra fuel to kind of atone for that loss of fuel that you'd normally be getting out of your jets. Now, a real quick note here I want to make is on my cars I like to run a higher power valve number than normal. Now what Holley specifies is that you take your engine idle vacuum reading and divide it by 2, and that's pretty much the power valve you're supposed to have. So if you had like a engine vacuum of, like 13, you'd use a 6.5 power valve. So, but what I like to do, since Holley's come from the factory jet a little rich, and then the power valves are a little bit lower numbers, I like to jet my carburetors down a little bit, because then I get better efficiency under cruising conditions. But then I put a bigger, or a power valve that opens up it less or more manifold vacuum, I guess. So whereas normally, say I'm idling at 13 inches of vacuum, I should have a 6.5, but I may have a 7.5 or an 8.5 depending on how much pull is on the carburetor when I'm driving. So naturally when you hit the throttle, if you don't have a lot of it all depends on your transmission, your rear end ratios, what you can run, but I run around with a 5-speed and 411 gears, so I'm not really into the throttle too much at cruising, so I can get away with an 8.5 power valve with a lot smaller jets than what I would normally run otherwise. But anyway, a little bit about the power valve here, how to remove it. So it's found on the metering block behind your float bowl here. So you remove that with the 4 screws that come out, and then you have a gasket in between this metering block and the body of the carburetor. I'll slide this up here so we can see it. Now I like to pry in between here, and so it doesn't damage anything. You want to be careful to use a big enough screwdriver where you're not damaging anything, but you're a small enough one where you can wedge it in there. You definitely do not want to go in like this and stick it in between the metering block and the carb body. You always want to pry off this choke bell area. So anyway, we get in here, and usually it pops off relatively easily, and it shouldn't ruin your gasket, but sometimes they do, unfortunately. So you really don't want to be in here a lot, but you can see there's a lot of gasketry here and a lot of fuel tubing. So you can see that when manifold vacuum, which would be in here, pulls this open, it'll suck the diaphragm open back here, and then fuel from the float bowl will go in here, and then there's actually behind this 2 emulsion tubes, and on some carburetors, I'll hold this in the correct orientation here, so this is the top, Anyway, some carburetors have adjustable emulsion tube bleeds where you can, it's almost like changing jets, whereas most carburetors like this one and standard ones, it's a pre-drilled, but you can drill them out, tap them out for those jet threads. But anyway, that's pretty much how they're set up, and I'll include a picture of this right now. So basically the importance of a power valve is all economy and drivability versus performance. If you didn't have a power valve and you had these jets that were set up for idle and cruising situations, you would run really good, cruising around town and stuff, have a good air fuel mixture and all that, and your engine would be real happy. But the second you stepped on the throttle with these jets set up for the idle circuit and cruising circuit, you'd go just dead lean, because what will happen when you open the throttle is your manifold vacuum drops. So the fuel being supplied through these jets will also be decreased. So it causes some issues there, where then if you wanted a jet for performance, you need bigger jets. Well, that's the reason that you have a power valve. So you can have your jets set for economy, plus with your power valve and your power valve system here, when you go under full throttle conditions, or moderate to full throttle conditions, whatever you have there, it'll allow in more fuel. So when that manifold vacuum drops and it allows in that extra fuel, you stay at the proper fuel mixture, and you continually make power through the circuit. So, and also coupled with that, you have secondaries, but they're a whole different topic there. So, but they're usually jetted bigger for a reason. So you're normally running around town on your primaries. So that's why you have a power valve, so that when you get into the power situation, this whole system will work together to pretty much be the same as the secondaries. Now double pumpers, they tend to have a power valve on either side. Now I kind of warn against putting a power valve block off deal on the primary side. That's really not what you want to do. But on the secondary side, you could get away with doing it if you have some drivability issues, and then just jetting up about quite a bit. I think it's 5 to 8 jet sizes I've experienced. It's quite a bit without a power valve on a double pumper. So with the 650 double pumpers I've ran in the past, I got to really jet them up. But anyway, that's a general overview of the power valve system and how it works and how to set it up. Again, you need it because you want these small for cruising, but when you really step on it and your manifold vacuum drops and you're not getting as good a pull through these jets, you really want this to open, so that when it does open up, it will allow the extra amount of fuel to atone for the smaller jet size. So you'll have performance and economy and drivability all in one setup. So it's really nice, especially these Holley carburetor setups. So anyway, that's pretty much all the ideas behind a power valve. And again, keep in mind what I said about the power valve in relation to the jets, in relation to your engine setup. Like I said, I get better economy because I can run bigger jets, and then a power valve that opens up sooner. But anyway, there you have it. I hope that answered any questions you ever had about the power valve system, and is a little bit enlightening. So there you go.